If you're watching the video, you need to pause it and basically make sure that you can do these 3 questions. So go ahead and pause it, and when you're ready, hit play. Okay, so here's the answers. The first question was, do these 3 sides form a right triangle? The 2 short sides would be legs, and the longest side is always the hypotenuse. And so we square all of them, but we put the legs on the one side of the equation, and we put the hypotenuse on the other. The legs are 6 squared and 7 squared. The hypotenuse is 10 squared. And then we go see if the 2 sides equal each other. Well, this is 36, this is 49, and when you add them up, it clearly does not equal 100. So no, it's not a right triangle. If the 2 sides had equaled each other, yes, it would have been a right triangle. And number 2 is pretty easy. How many legs does a right triangle have? They have 2. And so I drew a right triangle here, and it looks like I forgot to put in my right angle sign here. But the legs are always touching this right angle. Okay, and we went over that, and the hypotenuse is always the side opposite of the right angle, and it does not touch the right angle at all, like the legs do. So that's the hypotenuse. And then what's the abbreviation we use for the hypotenuse? It's C. Now, if you missed any of these, you really need to go back and practice a little bit more identifying the legs and the hypotenuse, and then the rest of the material will become a lot easier. But until you get this part down, for questions like these, it will be a hindrance to you. So heed my warning there and do what you need to do to get better. Now, before we jump into the Pythagorean theorem, here's a simple question. How do we solve equations like this? And let's just focus on this first one right here. Please do not say the answer is 10. I know the answer is 10, or at least one of the answers. But how many people have already forgotten that negative 10 times negative 10 is also positive 100? So when I say how do we solve it, I'm talking algebraically. How do we actually solve these types of problems? When your variable is being squared and it equals another side of the equation, this is what you can do that lets you be able to solve it algebraically, and it takes a lot of thought off. So when it's raised to the second power, your exponent there is 2, and it's on your variable that you want to solve for, you can do this. You can take this exponent away and put a square root sign on the other side of your equation. And what this is telling us is that, you know what, the square root of 100, or a number times itself, equals 100. That's what x is. And that's basically what we were asking ourselves without trying to solve it algebraically, is we were going, what number times itself equals 100? Well, here's the same thing. If you type in a square root of 100, it tells you what number times itself equals 100. And we should know that it should be positive or negative 10 is the square root of 100. So we know that x equals positive 10 or negative 10. Now, because we're working with triangles and usually we're trying to find the length of everything, we'll only be using the positives on this, but I just want to throw that out there. How do we solve this one? Well, since x is being raised to the second power, we rewrite the x here without the second power, right? And we put a square root sign on the other side. It's a legitimate algebraic move that lets us free up this x all by itself, and then we can run this through our calculator since we have no variables there, and we know it's positive 6 or negative 6. And same thing's happening down here, except for now we've gotten into this situation. Ooh, the square root of 85 is not pretty. If we have our calculators, we can use the square root, and we see that it would be rounded to about 9.22. Okay, but I'm not a big fan of doing that. So much of algebra, we just need to simplify our square roots. And do you remember how we do that? 5 times what equals 85? 17 is the only thing that I know. And so we're fine. We've simplified this down as much as we can. We don't have 2 numbers that repeated, so we could flip one to the outside. If you recall, when we looked at the square root of 8, if we simplified this, that was 4 times 2, right? But then this 4 broke down into 2 times 2. These 2 would cancel out, That gets us 1, 2 on the outside, but this 2 is left on the inside of the square root, and this would have become our simplified answer of 2 radical 2. So that skill comes back to play when we get into these types of equations at times. Won't be seeing that today, though. I just wanted to set you up for probably the next couple of days, next week or so. Here we go. Pythagorean formula. This is what Pythagoras came up with. This is what we've been looking at. This is the hypotenuse. This is the two legs. We square the two legs and add them up and see if it equals the hypotenuse squared. This time, I give you two legs of the right triangle, and it's your job to go through and find the missing leg length, in this case x. And do we remember what this side of the right triangle is called? Hopefully someone at this point has already said the hypotenuse, or you've been thinking it in your head. So this is the hypotenuse, and that means that it's also C. So let's just write C under here. And now let's get the highlighter, and let's use the pink. These two sides are our legs. So let's go ahead and write in legs. That way we can get used to seeing those again. And I'm going to make this one leg A, and this one I'll make leg B. So now we just plug these into our formula. Let's see, our hypotenuse, we don't know what it is. So that's an x, but it is squared. Okay. Our A is 3. But we're going to take this 3 and we are going to raise it to the second power. We're going to square it because that's what this relationship states. The square of the sum of the legs equals the square of the hypotenuse. And here's leg B, which is a 4. See, here's 4 inches. This is the second leg we haven't used yet. And we're going to square that one. So let's go simplify it and see what we have to work with here. 3 squared becomes 9, and 4 squared becomes 16. Okay, so got interrupted there. Let's get back on track here. We plugged in our leg values. We don't know our hypotenuse value, so we plugged this x in, and we went through, we squared our legs, and now we're just simplifying everything. And what we just went through was we said, how do we get this exponent off of our variable? That's what we did before we got to the screen, and we said, just put a square root sign over this side. Now we only do this if it's raised to the second power, because this is x squared, so we put a square root on the other side because it pretty much asks us the other side of the question, if you will. Here it says what number times itself equals 25. When we flip this power, the square power, over and make it into a square root on the other side, it's going to ask us what number times itself equals 25. So again, it's asking us the same question. It's just we kind of wrote it in a different way. Think of it as like print and cursive. It's the same thing, but it looks different. And then, hey, you know that it equals 5. I also know it equals -5, but have you ever seen the length of a triangle being negative? No, because the distance or length of something is always a positive amount. So we'll just use the positive one there, and there we go. This side of the triangle is 5 inches. Please note that this is a very famous right triangle, 3, 4, 5. A 3, 4, 5 is always a right triangle. So if you see the legs are 3 and 4, commit it to memory that this is a 5, and that might save you 20 or 30 seconds worth of work in the future. This is your problem that you need to attempt right now. Pause the video, and then we'll go through and check your work. Okay, so let's see here. Let's go identify our hypotenuses and our legs. This is the hypotenuse. It looks like that is our unknown. And these other two sides of the triangle, because they touch the 90-degree angle, are our legs. So let's go fill in our values. Hypotenuse is C, so that will be x. We need to square it. The first leg I see here is a 4.2, so we'll square that. And then here is a 6.8, and we'll square that. Let me get the plus sign in there, so I forgot that. And now let's just go through and work this out. 4.2 times 4.2 would be actually 17.64. So x squared will equal 17.64 plus, let's see, 6.8 squared would be 46.24. So now we can actually add these two amounts together. Okay. And I get 63.88 unless I've made a mistake here. Hopefully I haven't. And now I'm going to have to break out the calculator for this one after I get it set up. X to the second power. That means x squared. How do we get rid of that second power? Oh yes, when it's squared, I can put a square root on the other side, and it works beautifully to free up my variable all by itself. And so now I can say, what is the square root of 63.88? For this one, definitely want to use a calculator for. X basically equals 7.99 feet. And so that's rounded to the nearest hundredth. X equals 7.99 feet. Do a quick check here. I forgot to tell you this one on the last problem because I was so concerned making sure that you knew about the 3, 4, 5. If you know that the two legs are 3 and 4, that the hypotenuse is 5. I was so concerned about getting that information to you that I forgot to tell you to use a little bit of common sense. We know the hypotenuse is the longest. Is this the longest side of this triangle? Yes. If you're ever solving for the hypotenuse and your answer is smaller than your legs, you've made a terrible mistake, or perhaps it's not a right triangle.